Here is our system in example 3E. Okay, and this one's an oddball because look at it. You've got two equations and three variables. Okay, so we haven't encountered this just yet as far as solving a system where the number of equations is different from the number of variables. Okay, even though that's the case, okay, you can still do the problem the same way using Gauss-Jordan elimination. Okay, so watch. Okay, first thing we're going to do is convert this to matrix form. Okay, so our very first matrix, okay, you take the first equation, that becomes the first row of the matrix. So you're going to have 3, -9, 12, draw your vertical bar, 6 on the other side. Okay, and then take your second equation and make that the second row. So we're going to have -2 in front of x, 6 in front of y, -8 in front of z, -4 on the other side of the equal sign. Okay, so how is this going to work? Because, you know, it's a little, it's uneven kind of, it's unbalanced. Okay, still it's going to be the same thing. You're going to start in the first column. Okay, you're going to put a 1 on the main diagonal. Okay, 0 out the rest of the column. Move on to column 2. Put a 1 on the main diagonal, 0 out the rest of the column. Okay, then we'll move on to column 3 and we'll talk about that when we get there. Okay, so for our next matrix, okay, we want to, starting in the first column, we want to change this main diagonal element to a 1. Okay, so you know, you have options here. You can switch rows. That's not going to do us any good. Okay, so our best bet is going to be to take the entire row 1 and divide by 3, because 3 divided by 3 will give you that 1. Okay, so our row operation is going to be row 1 divided by 3 is going to become row 1. Okay, so we're just going to take every element in row 1, divide by 3. Okay, notice there is no change to row 2 at this time. So we're going to leave row 2 alone. Okay, so here we go. All right, so take everything in row 1 and divide by 3. So I'm just going to eyeball it here. 3 divided by 3 is 1. -9 divided by 3 is -3. 12 divided by 3 is 4. 6 divided by 3 is 2. Okay, so there we go. There's our second matrix. Okay, we want to keep working in this column. Okay, so now that we've got our 1 on our main diagonal, we have to 0 out the rest of the column. So this 2 needs to change to a 0. Again, we're going to have to employ our third row operation. Okay, so if we want to make a change here, we're going to have to add a multiple, or we're going to have to take row 2 and add to it a multiple of a different row. Okay, so we are trying to cancel a -2. Okay, what is going to cancel a -2? Well, a +2. Okay, since we're in the first column, we need to multiply the first row by something. Okay, so we're going to do 2 times the first row and add it back to the second row. Okay, if you do that, you're going to get 2 times 1 is 2. That would put a 2 here. Okay, add it back to the second row. Okay, 2 plus -2 is going to give you the 0. Okay, so that's going to be our next row operation. Okay, so to get the third matrix, we are going to do +2. I don't know what I'm doing here. We're going to do +2 times row 1, add that back to the second row, and that will become the new second row. Okay, all right, so our next matrix, okay, row 2 is changing, so we're going to leave row 1 alone, and then I'll go out to the side and do my work. Okay, so we're going to do 2 times row 1, so take everything in row 1, multiply it by 2, that's going to give us 2, -6, 8, and 4. Okay, add that back to row 2, so go to your previous matrix and grab row 2. So let's write that down. All right, and here we go. Okay, when we add these numbers, we're going to get 2 plus -2 is 0, -6 plus 6 is 0, 8 plus -8 is 0, 4 plus -4 is 0. Okay, we get a row of zeros. Okay, all right, as soon as you see a row of zeros, okay, that screams infinitely many solutions. Okay, so we can stop. Okay, it would have been possible, like had we not gotten a row of zeros, okay, you would have continued on and you would have gone to the second row, put the 1 on the main diagonal, and then zeroed out the rest of the column and then gone from there. Okay, more than likely you would have also gotten infinitely many solutions. okay? So like I said, row of zeros, okay, that's indicating or screaming at you, this is infinitely many solutions, okay? All right, so we have to parameterize the solutions. You do that anytime you get infinitely many solutions, okay? So to do that, you need to go back to your last matrix, okay? The one you left off with, okay? The second row is just telling you there's infinitely many solutions, okay? The remaining row, okay, is going to help you do the parameterization, okay? So we're going to translate this first row into equation form, okay? So remember what's going on here. You have, if you go back and look, remember you have three variables, x, y, and z. Okay, so this first column, those are numbers in front of x. Second column are numbers in front of y. Third column, numbers in front of z, equal sign, number on the other side. Okay, so if we take this first row and translate it back into equation form, that's going to tell us 1 times x plus -3 times y plus 4 times z is equal to 2. Okay, um, so we are going to clean this up. That's going to give us x minus 3y plus 4z is equal to 2. Okay, and that's the only other row that we have to translate at this point. Okay, so from this, we're supposed to do the parameterization. Okay, so you're probably wondering, what in the world do I do here? Okay, one of these variables has to be your t. Okay, and then you're supposed to write the others in terms of it, of the other one, or in terms of the t, sorry. This one's a little bit strange, okay? Because you look at this, you only have this one equation to go on, and you're probably like, well, which variable do I solve for? Okay, well, since you only have this one equation, the answer to that is it doesn't matter which variable you solve for, okay? Just pick one and solve for it. You can solve for x, you can solve for y, or you could solve for z. It's your choice. When I see this, okay, when I look at this, see how the number in front of x is 1, but if you have a -3 in front of y, you have a 4 in front of z. It's easiest to isolate the x because the number in front of it is 1. So all I'm going to do is I'm going to solve for x by moving the 3y over. So I'm going to add 3y to both sides, okay? And I'm going to move the 4z over, okay? The 4z here is positive. So to undo that, I need to subtract 4z from both sides, okay? So on the left, -3y and +3y cancel, and then +4z and -4z cancel, and it leaves x all by itself, isolated, okay? And on the right side, we are going to have 3y minus 4z, and don't forget about the +2 was already there, okay? So now one variable is written in terms of the other two, okay? You've solved for one of the variables. Remember, x is on the left side. On the right side, you don't have any x's. That's what it means to be solved for x, okay? Now, which one of the variables is going to be the t, okay? Well, you've got to look at this statement and say, which one of the variables am I in charge of, okay? Again, this is different from what we've seen in the past. You're actually in charge of both y and z, okay? You get to pick the y, you get to pick the z, and then you plug those values in, and x has to follow the rule, okay? Whatever y is and whatever z is, x is going to be determined by 3 times the y value minus 4 times the z value plus 2, okay? So you're in charge of both x and, or sorry, you're in charge of both y and z, okay? So both y and z are going to be parameters, okay? So what that means is, okay, you're in charge of y and z, so we're going to let y be t, okay? It's a parameter. That parameter just means you get to pick it, okay? Now, z is also a parameter. I'm not going to call it t, because if I call it t, that means that y and z have to be the same number, and they may not be the same number, okay? So I'm just going to use a different number, say different letter, say k, okay? So if y is t, z is k, those are the parameters, and I'll even write that there, fancy word. That's going to force x, according to this statement, to be 3 times y, so 3 times t, minus 4 times z, so 4 times k, plus 2. Okay, so you can write your solution set this way. You always write the x value first. Okay, so I made a funny looking 3 there. Let's change that. So 3t minus 4k plus 2, comma, then the y value, which is t, then the z value. Remember, the order matters. It has to go x, y, z. Okay, so here's your answer to this particular system. Okay, infinitely many solutions. Here is the parameterization. Okay, so again, if you encounter infinitely many solutions, I asked you to do the parameterization and to do one specific solution. Okay, so let's go ahead and get one specific solution. Okay, so all you have to do is pick values, make up values for the parameters. So you get to pick an x value, or sorry, you get to pick a y value or a t value and a k value. Okay, so again, I'm just going to make it easy here. Okay, let's make t equal 0. Let's make k equal 1. Okay, they could be the same thing. You could have picked 0 for both. Okay, I'm just making up numbers. You can pick anything you want. Okay, so if I choose these two, okay, then that's going to force the x value to be 3 times the t value minus 4 times the k value plus 2. Okay, so that would simplify to be 0 minus 4 plus 2 is negative 2. Okay, so one specific solution would be the x value, negative 2, the y value or the t value, which is 0, and then the k value or the z value, which is 1. Okay, so here's one specific solution. Okay, negative 2, 0, 1. This would be your x, your y, and your z. Okay, and you can go and check to see if that works. Okay, so if we check this one specific solution, which is negative 2, 0, 1, okay, if you plug this variable assignment into both of these equations, okay, you should get true statements. Okay, so let's check equation number 1. Okay, we're going to have 3 times x minus 9 times y plus 12 times z. Okay, let's see what we get. We get negative 6 minus 0 plus 12. That's going to give you positive 6. Okay, so that one checks out. Okay, and then check equation number 2. Okay, we're going to get negative 2 times x plus 6 times 0 minus 8 times 1. That simplifies to be positive 4 plus 0 minus 8, which is negative 4. Okay, so that one checks out as well. Okay, so that is one specific solution. Okay, all you have to do to generate additional solutions is pick another t value and another k value and plug them in. Okay, so that is the answer to this particular one. Okay, and like I said, most of the time when you see a system like this where the number of equations differs from the number of variables, you will likely end up with either infinitely many solutions or some of them it will be no solution. Okay, so in the case of infinitely many, you're going to have to parameterize. You may end up with more than one parameter, so keep that in mind. Okay, and so that's how you work this one.